First, let's understand for nth root of a complex number z, okay, the geometrical meaning. This is an Argand diagram with the real axis on the x-axis and the imaginary axis on the y-axis. Okay, and your polar form of the z is written as r cos theta plus I sin theta, where r is the modulus and theta is the argument along for this particular complex number from the anti-clockwise angle from the real positive x-axis. Right? Okay. This is the polar form. Right? Okay. Next, let's talk about the nth root of this complex number z. So that means, let's start with an example. Let's say n is equal to 5. What that means is we are finding the fifth root of z, or the 5 roots of z. Okay, 5 fifth roots. Okay, that's the exact meaning. Z to the power 1 by 5. We are let's take these 5 roots as w1, w2, w3, w4, and w5. Geometrically, this means there are 5 fifth roots. Okay, 5 of these fifth roots: w1, w2, w3, w4, and w5. Okay, these fifth roots are in a circle because they all have the same magnitude, okay, or the same modulus. Hence, they are in a. You can express them as a circle, with the circle having the radius as equal to the modulus of any of these complex roots. Okay. Before moving ahead, we first need to review complex number multiplication again. So let us say there are two complex numbers, a1, b1. They belong to complex numbers. E stands for belongs to, and C is the complex number symbol. So a1 and b1 are complex numbers, and let's say we have represented both in their polar forms. a1 is equal to a cos theta a plus I sin theta a, or another way of saying it is a cis theta a, where a is the modulus of a1 and theta a is the argument of a1. Okay. Similarly, b1 is also the same thing. Okay. Now, when you multiply two complex numbers, what happens is their moduluses get multiplied and their angles get added. Right. That is the premise about the roots as well. So coming back to the fifth roots example. So w to the power n is equal to z. Okay. When n is equal to 5, w to the power 5 is basically equal to z. That means all these 5 w's, w1, w2, w3, w4, 5, they all multiply as complex numbers to give you z. Right. Now, since all 5 w's have same modulus, okay, they all have same modulus because they are just z to the power 1 by 5 as represented in the circle earlier, right? As represented in this particular circle. They all have the same modulus, right? So coming back to the polar equation that we had of z, okay, z was equal to r cos theta plus I sin theta. Okay, now let's apply Demoivre's theorem to find at least the first root. Okay, so when you do z to the power 1 by 5, you get r to the power 1 by 5 and cos theta by 5 plus I sin theta by 5. So this gives you the first root. Okay. So whatever value of theta was there, and it's represented as already shown you in the image, it's w1. That's what we've got. Okay. It is of course going to have a smaller modulus, r to the power 1 by 5, right? Now we can find all the rest of these, okay, w2, w3, w4, w5 in the following way. Similarly, let's talk about the second root, w2. So once you have got w1, okay, the ideology, the geometrical meaning is that you want to divide this unit circle into 5 equal sectors. Okay, that's how you can map every root. Okay. So w1, once you have got, okay, now you know that the complete interior angle is 360 degrees, right, or 2 pi radians. So now if you want to find 5 sectors, so 1, 2, 3, 4, 5 sectors, so you divide 360 by 5, right? So the geometrical meaning means that to get to w2 you need to rotate anti-clockwise by 72 to reach to W2. Or another way of saying it is if W1 is theta by 5 degrees. Okay, let me write that angle in another particular line. Okay. Let's say if this angle is theta over 5, to reach to the next one, you need to add 72. Now that can be said as uh, this complete angle from the positive x-axis can be said as theta over 5. This can be said as theta over 5 plus 72. 72 can be written as 360 divided by 5, right? Or 2 pi divided by 5. That's how you reached from W1 to W2, right? So you just basically rotated, or you can just say you have shifted W1 to W2 by going further an angle by that much, right? So similarly, once you reach here, you can add again 2 pi by 5 to reach here. Okay, so the geometrical connotation becomes this, that if you have this one was theta by 5 plus 2 pi by 5, this one will be W2 plus 2 pi by 5, right? Further 72 degrees further anti-clockwise like that. And this is first the geometrical interpretation. Then comes the formula. The formula says that yeah, this is just the interpretation. This is just the written form of W2, which is the polar form and the Euler form, right? So now if we come to the formula, so the formula implies that to find n roots of a complex number, okay, you have two values. One is n, okay, and one is k. Okay, k always starts from 0 all the way to n minus 1. Okay, n is the number of roots and the nth root that you want to find. So let's say k always starts from 0 all the way till n minus 1. So k will go at most till it will start from 0 and will go at most till 4, right? And applying the formula, we have W1 equals to r to the power 1 by 5 times theta by 5. Don't forget, this is all e to the power I, and times all of this, e to the power I times all of this. Okay, we are writing it in Euler's form because it's a little shorter. So theta by 5 plus 2 times 0 times pi by 5. Okay, then so if you put all of this to 0, this just becomes 0. So that gives you the first root. You can see r to the power 1 by 5 e to the power theta by 5i, which we found out, right? Theta by 5 as the first angle of W1. Similarly, W2 also we found, and all this way we can find all the way till 5 roots. Okay. So finally, the application, once we've written down all the roots, now if you just see the roots, W1, W2, W3, W4, W5, if I've written it down in Euler's form only, now if you multiply these roots, okay, you will see that the moduluses multiply to give you r to the power 5 over 5, which is just r, which is the modulus of z, right? And if you add all the arguments, which you do when you multiply complex numbers, it becomes 5 theta by 5, which is nothing but theta, and all of this gets added to 2 plus 4 plus 6 plus 8 gets added to 20 pi over 5, which becomes 4 pi. So if you have the angle theta and you have 4 pi, okay, so you are actually back there only, because the period of cos and sine both is 2 pi, right? So you went all the way 360 like this, and you went once again 360 like this, so you're back there, right? So it's the same value, which is equal to z. So hence this is how we use to find the this is the application of nth roots concept of complex numbers.